This lecture was established in 1994 in memory of John Hans Lovier in recognition of the family's many years of friendship with AMI-Quebec. It became the Edith and John Hans Lovier lecture in 2010 after Edith passed away. The event has been a highlight on our calendar and an opportunity for us to host world-renowned experts on topics related to mental health and mental illness. AMI-Quebec is a community-based organization in the front line of mental health field. For almost 40 years now, we have helped families to cope with the hardship they often experience when mental illness strikes. Our programs are too many to count or to name, and I would like to encourage you to visit our website. There is wealth of information there, and you can get lots of information about our programs, services, etc., and then give us a call, of course. And more than that, we moved to our new home a few months ago, and on December 1st, we are going to have an open house from 5 to 7. We invite you to visit us, to hear more about what we are doing, and to see where we offer our services. This annual event has been, as I said, the collaboration with the Department of Psychology of Concordia University since its inception, and we are grateful for the department's ongoing support and interest. I would like to invite Dr. Virginia Penhune to say a few words on behalf of the university.
So it's my very great pleasure to be here this evening. I'm Dr. Virginia Penhune. I'm chair of the Department of Psychology, and I'm here to welcome Dr. Dolores Malaspina for this evening's lecture, and really to also thank very much Amir and the entire AMI-Quebec organization, as well as the Lovier family, for their support of this lecture and for their willingness to collaborate with the department. This is something that's quite important to us, to have the opportunity for our students, for our faculty, to be able to hear about cutting-edge clinical research, and also to join with the community in hearing about some of the advances that are going on. So without further ado, I'll again thank Ella. I'll thank all of you for coming out tonight, and I'll welcome Dr. Dolores Malaspina.
Tonight's lecture will focus on the nature-nurture puzzle and shed some light on this complex issue. Scientists have been studying mental illness for a long time, trying to tease out what triggers mental illness. The 90s were dubbed the decade of the brain, with a strong emphasis on the role biology plays in mental illness. Later studies explored environmental influences that could play a role in mental illness. The research of Dr. Dolores Malaspina, tonight's guest speaker, explores both nature and nurture in an attempt to understand what may be the risk factors that are associated with mental illness and what could protect someone from developing the disease. Dr. Malaspina is the Anita Steckler and Joseph Steckler Professor of Psychiatry and Child Psychiatry at New York University School of Medicine and the former chairman of the Department of Psychiatry. At New York University, she directs the Institute for Social and Psychiatric Initiatives program of research in psychiatry. She completed her psychiatry residency at Columbia University, serving as chief resident and research fellow and advancing to a professor position before relocating to New York University. She attended medical school at Rutgers University in New Jersey and held additional degrees in environmental biology from Boston University and zoology from Rutgers University and epidemiology from Columbia University. Dr. Malaspina's clinical and epidemiological research has been well funded by NIH, including grants for career development and for the mentoring of beginning investigators. She has authored 275 manuscripts and is the new editor of the International Journal of Mental Health. She received numerous awards for her research and teaching. Dr. Malaspina is an active member of the steering committee for the American Psychological Association that considers revisions to the DSM-5 and future future diagnostic approaches, and previously was the author of the DSM-4 revised and DSM-5. Finally, for the last 8 years, she has hosted the weekly 2-hour Psychiatry show on the Sirius XM Doctor Radio channel, providing psychiatric information to the public. We will have some time for questions and answers at the end of the presentation. You can write your questions, we'll pick them up at the end. And without further ado, I would like to welcome Dr. Dolores Malaspina.
I want to thank you for that lovely introduction and for having me here. I have a passion to solve the puzzles of schizophrenia, but obviously another one to talk about it and to try to teach and explain. I am myself a family member. My sister has schizophrenia, and that's really what launched and perpetuates my own career, as some of you can appreciate. So tonight I'm going to be speaking about nature and nurture, the seeds of mental health, and perhaps you see them as quite separate. And perhaps at the end of my talk, you'll see much more overlap between these domains. Certainly psychiatric diseases are major public health burdens. 1 out of every 4 adults has dysfunction, periodic or continually, from a psychiatric condition. These account in the developed world for the greatest healthcare costs, depression alone, and that will be true worldwide just by 2020. So better understanding of psychiatric conditions is a question for each and every family. Now, what are the determinants of behavior? So we had a very, very long time when we looked up at those exposures and we wondered what might have caused someone's illness. In schizophrenia, for example, unfortunately, mothers received a great deal of scrutiny for quite a while, but other exposures had been considered as well. And then we moved to the genetic period, when the pendulum swung and our expectation was that genes could be found that would explain these conditions. I'll add to it a current perspective that's very important, which is the one development. And that's our growing awareness that it's exposures over development, particularly in some critical ages, that may be the most important risk factors. And I sometimes here will talk about psychosis, but in fact, the risk factors for the different disorders are surprisingly common. Perhaps genes might differ, but the new data will show us that that's not necessarily the case as well. Certainly all of the research together shows that there are some things that really can be protective against an array of mental and metabolic disorders. One is prenatal care, another is a nurturing environment. Born of a wanted pregnancy turns out to be a strong protective factor against a host of different conditions. Wantedness, intelligence of someone can be an advantage, although it certainly doesn't protect you from developing an illness. An enriched environment, and each of these are lectures in and of themselves. We know that social support is very important. Humans are mammals, and we need one another. And being cut off from social support can lead to a deterioration. Unfortunately, some of our illnesses cause people to separate and lose that support, and trying to keep people in support networks that don't overwhelm them is a goal of current care. When people do develop difficulties in functioning, we know that early interventions are very protective. Psychological, psychotherapeutic, environmental changes close to the time of onset can do a great deal to minimize the risk for a condition. Then you want to be lucky and not have predisposing factors. One of those is cannabis. Drug abuse is a risk factor for many things, and in turn, early stress is a risk factor for substance abuse. But it turns out that cannabis in particular is the substance that's most highly linked to later psychosis and later deterioration in some aspects of cognition. Now, at a time when cannabis is being proposed for legalization, one hopes that the awareness is there, that cannabis exposure in adolescence greatly can disrupt the development of the brain. I've seen clinically in New York some families who, to discourage their young child from being exposed to alcohol, offered them some joints. Don't do that. Not a good idea. Not a good idea. In fact, cannabis is linked to later psychosis. Alcohol abuse is not directly showing that linkage. Head injury is a risk factor, certainly for depression and attention abnormalities, but also for psychosis, so those bike helmets make a difference. Head injury in middle age is a risk factor for later dementia. So we see for these different disorders the intriguing commonalities between different factors. Now, psychosis that I'll mention is a state that can occur in a mood disorder, in substance abuse, in schizophrenia, in schizoaffective disorder. This is the presence of psychotic symptoms, delusions and hallucinations, disorganization of behavior, deficits in experiencing and expressing emotions, with a decline in functioning. And the onset is usually in late adolescence or early adulthood, which is when so many of the serious mental illnesses first show themselves. Psychosis is related to this increased risk for prenatal adversity and also to childhood infections. We see an excess in the children of immigrants and even an excess in those who are born in the city. So it's a very intriguing disease. Some of the earlier biological ideas of psychosis were that it resulted from an early dementia. We know dementia can set in, in the later life, in the 60s or 70s, and be associated with some loss of cognition and loss of functioning. The people who first described psychosis and schizophrenia, particularly Emil Kraepelin, observed that here were a bunch of young people who were functioning fine, and then in their late 20s they began deteriorating. And he called the disease dementia precox, dementia of the young. And his focus was not on psychosis or these other symptoms. He thought those were just secondary to some dementing process. And that's this idea of a loss of brain tissue. That's different than the idea of a developmental condition, which also has support, as do depression and metabolic and bipolar disorder. And this is the idea that it's prenatal adversity that is influencing the fetus and will cause the emergence of psychosis or mania or depression at some later time as the brain matures. And whether there's a latent lesion that's left there from development that just doesn't show itself until brain maturation, or something goes awry in brain maturation, will be where I finish this talk actually today. Now, what are some of the exposures that we've linked to the risk for severe mental illnesses? Well, I mentioned maternal health, so maternal preeclampsia or diabetes, a host of maternal medical conditions, and then the prenatal exposures. I've mentioned some of them to you, but likewise RH incompatibility, APO blood group incompatibility, obesity of the mom and anorexia of the mom can increase the risk. So many of these things we've talked about as possible determinants of developmental problems. We also see an excess of severe mental illnesses in the Northern Hemisphere for people born in the late winter or early spring. And I mentioned immigration and being born in the city. Then we move into childhood. And robustly, we see trauma, sexual abuse, physical abuse, stress as very important risk factors for later psychiatric diseases. Likewise, at the time of birth, being born too early or too low a birth weight is a risk, not just for psychiatric conditions, but also for metabolic conditions like obesity and insulin resistance, diabetes, lipid diseases. We see a lot of overlap in risk pathways between severe mental illness and metabolic conditions. Now, if I tell you that these factors double or triple the risk for schizophrenia, that sounds enormous to you. And people who get the flu and know that it can double or triple the risk for schizophrenia, well, they just run right to their doctor. But what does it mean to triple the risk? Well, about 1 in every 100 people has schizophrenia. We used to say 1 in every 100 people worldwide, but that's not actually the case. There's some local variations, and so it can, vary 3 or 4-fold, but that still means 0.33% to 1.5%. But if I'm saying that this exposure of the mom, to this risk factor will double or triple the risk, well, then we're scratching our heads and we're thinking, well, gee, if 1 out of every 100 people develop schizophrenia without this risk factor and it triples the risk, then 3 out of 100 people will get it. So what's the odds, even if you have that exposure, that your kid would probably not have a problem, right? Well, let's see, 3 out of 100 minus 100 out of 100 means that even if it triples the risk, 97 out of 100 pregnancies that have that exposure would not have the condition. And I point this out to you because if you study severe mental illness, or you have severe mental illness, or a family member does, people are always trying to see what was it, what can explain this. And I want to really lighten that burden if anyone has taken it on by giving you a sense that most of these exposures are not at all increasing most people's risk for the diseases. But as a scientist, they give us important clues, and that's really important because we want better prevention, better treatment, and we really want to understand. Now, that person Kraepelin who defined schizophrenia for the first time and called it dementia praecox, he made this observation that some of the visitors, the relatives, themselves might have a taint of mental dysfunction. And based on that, we've done 100 years of family, twin, and adoption studies to try to understand what is it that runs in families. If you read a lot of the genetic studies and you have a family member, you're wondering, could I have this gene or that gene? I hope nobody is ever having their DNA examined to decide whether or not they might have, a child at this point. Because it turns out that most people with bipolar disease or schizophrenia or severe OCD have no family history at all. These conditions are appearing in the absence of a family history. And that is what is compelling, or what I found most intriguing. If most people with these disorders have no family history, well, where are the disorders coming from? On the one hand, you might say, well, if they're not coming from mom or dad, well, then that proves it must be the environment. In the 60s, they said it was schizophrenogenic mothers, or maybe now you'll think other things, and that would be the thought. Whose fault is this? How do we understand that? But what I would say is that there are other explanations for understanding where schizophrenia might come from if it's a genetic disease, and if there's no family history. And I put my attention to that early on, at first comparing cases who came from families with many, many generations of individuals who had psychosis or bipolar or severe depression, and called those the familial cases, and comparing that to the individuals with no family history. And I started to see signals that these groups were different. And I always had in the back of my mind, dating from medical school, an interest in the idea that maybe father's age was related to the new mutations. That was because I learned at a lecture in medical school that it was the age of the father that predicted who had achondroplastic dwarfism. I remember at the time thinking, well, that's odd. How could that be? You know, the father's, giving some DNA. How could you have a disease related to the age of the father? No, we've come a long way since then. It turns out in humans, as in all other species, almost all of the new mutations, all of the new changes in the genes are arising in the father. And they arise in proportion to the age of the father. Now, some of those mutations have given us the stuff of evolution, right? It's not all a problem that new genes get introduced into a population. But could it be that this was related to the risk of schizophrenia? Now, you may be wondering, why would it be the age of the father? And the answer is that male and female germ cells are very different. So when a woman is born, she has all the egg cells that she will ever produce. And they're waiting there in her ovary for just the right time to be ovulated. But by contrast, beginning in puberty, the spermatogonia that will produce the sperm are dividing constantly, every 17 days. So the DNA is being copied and the cells are dividing. Well, it turns out that in that process of dividing, a cell can accumulate a mutation. Now you notice if your dermatologist had told you to stay out of the sun, and you have little brown dots spreading someplace on your face, those are mutations that have happened over aging with the sunlight exposure. So as cells age in our body, they're prone to develop mutations, and some of those can become a cancer. Well, the cells in the spermatogonia can also accumulate mutations, and our question was, could those be related to the risk of schizophrenia? Now, new mutations had been proposed for schizophrenia way back in the 1950s because scientists there studied these large families and they have detailed records for hundreds of years. And they were curious to see what might explain the disease. And they saw that for many families there was no mental illness at all. And then suddenly it appeared and it became very prevalent in that family. And so they had the idea, could there be new mutations? But at that time it was thought that new mutations were really rare. We know now they're not rare, that there's usually about 6 new mutations in every generation, and the age of the father could amplify that. Here's just a little cartoon about it. So you have all those arrows, and they're pointing out those green dots, and those are called the hub cells. That's where the future sperm-making cells have lined up. Then beginning at puberty, they divide again and again and again, and I've shown you some green dots coming out of the second one down, and those would be spermatogonia that have the regular starting lineup of the genetic material. But you see, suddenly a purple dot appears, right? And what you notice is that purple dot, which is the mutation carrying spermatogonia, is getting bigger and bigger and bigger. So our interest is mutations that happen in a spermatogonia that make it divide faster. So those spermatogonia start dividing and dividing and dividing, and as dad ages, they outcompete the ones that don't have a mutation. And this is our proposal for this mechanism, and we call these selfish spermatogonia. You know, they're not jumping up and saying, look at me, I divide fast, but they are out competing the other spermatogonia, even though the risk to the offspring could be psychiatric illnesses. Now, it's not just psychiatric illness, that's what we're studying, but it had been known from the 1920s that it's a host of metabolic and genetic diseases when they first occurred in relationship to paternal age, and that includes cancers, it includes even color blindness from the age of the grandfather and Marfan syndrome. So we have a lot of genetic diseases we talk about, but they first appear in association with an older dad. by and large. So this is quite established in medicine in general. And you'll wonder, given that all of this knowledge has been around since really the 1920s and 30s and 40s, why in schizophrenia, when we saw an excess of the disease in last-born children, did we think it was cold mothers? Right? It was following that same profile that was observed for many other diseases, but the psychological nurture explanation predominated the biological explanation, and this back and forth occurs over and over again. Well, to see if paternal age is actually a risk factor for schizophrenia, you have to do a study. And to do a study where you look at a risk factor and an outcome, you have to do the right kind of study. We can't do our studies just at a hospital or a treatment center because that introduces a big bias. We call that a Bergson's bias because all those people are treatment seeking. Maybe they're different than other people who have the disease. And then even so, who should be the controls for a study that you do? So that was what drove me back to get an epidemiology degree after I had started running the schizophrenia research unit at New York State Psychiatric Institute. And my goal was to get what we call in the field a birth cohort. Because a birth cohort is an entire population of people that are studied before anybody has the exposure you want to look at and anybody has the disease. So that's an unbiased way to look at the whole population and see if you can explain the risk. Now you would think, well gee, if father's age is related to schizophrenia, Dolores, we'd have known it. And I did hear that statement many, many times early in my career, because we've been looking at these things for a very, very long time. Well, but in fact, maternal age is robustly associated with the risk for schizophrenia. And the way we did it is we went into the Jerusalem perinatal cohort. This is a study of 100,000 births, every birth in Jerusalem between 1964 and 1976. And working with the Ministry of Health in Israel, we had the identity, a double-blinded code for each baby born at that time, and we knew a great deal of information about the mother's health, the place of birth of the grandparents, parental education, a rich amount of data from the original study done by the Ministry of the Interior of Israel so that they could understand the health of children. And then we cross-linked all of that data into the psychiatric case registry. Now, you may wonder why all the good epidemiology research comes out of Scandinavia or Israel, and probably one reason is that there is a unifying health number for each person that is maintained in the Ministry of the Interior. So at any point in time, you even know which numbers of people are available to develop an illness. So as an epidemiologist, you go someplace where you can link different pieces of data together. So we had the data on these people's birth, and we layered in data about their schooling, about their physical health, their cognitive function in the military, when they got inducted, and then the schizophrenia risk, so that we could reconstruct a lifelong story and look at it with relationship to the risk factors. So this graph, this graph shows you on the bottom different age categories of parents, and if you can see at a distance really well, you'll see on the bottom we have less than 20 years, and then 20 to 24 years, and so on across to 50 plus years. These are age categories, so we take all the babies born and we put them in categories based on age of mom and ages of dad. Now, if I was only looking at the ages of mother, what you would have seen is that mother's age is a powerful predictor of schizophrenia risk. Now, we look at mother's age in medicine all the time, and women have the idea that as they get older, there's a big risk to their babies. But other than Down syndrome and some chromosomal rearrangements, the bulk, the vast majority of birth defects are due to the age of the father. So why do we say it's the age of the mother? Because people haven't looked at the age of the father. That's why. But if you look at the age of the father and the age of the mother, then you use statistics mathematically. So you can account for the age of the mother separately, then the age of the father, and then you can disentangle them. And when you do this, you see a tiny increased risk attributable to the mother's age for mothers in their late 30s and early 40s, a little tiny increase in that red bar. But when you look at the blue bar, the risk from father's age, you see it steadily increasing. And in this population in Israel, we could explain 25% of all the risk for psychosis based on father's age alone, right? So that's a very large proportion of the risk. And then we furthermore went with Avi Reichenberg, who studies autism, in the same birth cohort and found all the people with autism who had been born in this time. And we showed that father's age was even a bigger risk factor for autism, and then showed that you could explain all the excess of autism based on the increase in father's age. Now, father's ages are going up worldwide, and that's been true since, I think, the 1940s, following World War II. This is just a snapshot from Sweden and Stockholm, but the same is true everywhere. Mothers and fathers are having children later. And so it's a wonderful thing for people to have that flexibility, but could the later ages of parenting be a risk factor for medical conditions and psychiatric conditions? So far I'm talking about the possibility of genes and mutations, but let me digress now. You know, it's not just genes that provide the blueprint for our physiology and for how we will function. Here's a study of identical twins, and these are identical twins. That means they share all their genes. And even though they share all their genes, if one identical twin gets schizophrenia, the risk is only 40% that the other one will get schizophrenia. Right? So it's not all in the genes. In this cartoon, you see that even brain imaging differs between the two twins based on which one has the schizophrenia. So it's not all genes, something else is going on, and we want to try to understand that something else. And it brings us to some of the most exciting information we've learned in science in the last decade or more. And over my lifetime, we have moved from genetics, which is that double helix, around which all of our genes, the blueprint for our body and our physiology, is organized. That discovery was based on electron microscopy work and ideas of Rosalind Franklin, but like many people exposed to a lot of x-rays, she died of a cancer at a young age. But Watson and Crick took that data forward and took the idea of the double helix forward, and that brought us to the era of genetics. And if you've studied biology, you know that we thought there was a central dogma to life, and it was called the central dogma, which is that you have your DNA, the different genes, and then those get turned into proteins, and the proteins determined who you are. And that was very simple to learn in high school biology, much easier than what people have to learn now, because in fact, most of our genes are switched off, right? How does a gene get switched on and off? That is going to be some of the most important information about our mental health. And this is called epigenetics. Kind of above the genes are sets of switches, turning genes on or off. And some things that turn genes on or off are the exposures, the nurture, the substance abuse. So our interest is the epigenetic, gene expression, right? So you have some changes to genes where they get turned off, and guess what? They can be turned back on again, maybe by therapy, maybe by medication, maybe by support. There's this plasticity in our genetic makeup. Some changes to genes, though, can be passed on to other generations, right? So it's not just your genes that can be passed on, but sometimes an exposure can change the gene. There's a study of mice where you can show that highly traumatizing a male mouse at puberty on a single occasion, but with a horrible, mean, nasty mouse who comes into the little guy's cage and scares him, that will change the genes in the offspring of that father in the future, right? So an exposure of the father in puberty can change the appearance and the physiology of the offspring. So this is done by changing gene expression, and over evolution, it's been so important that it gets conserved, and it can be passed on several times. But then ultimately, most of these epigenetic switches fall away. So we've moved from our simple double helix in 1953, this elegant double coil of DNA, to some messy thing by 2013, because on top of that nice DNA, we have all these switches and histones and methyl groups, somehow turning genes on and off in this alive, dynamic way, based on our experiences, based on aging, based on medications. It's fairly remarkable. And this is a cartoon that shows you what that might be like. So in scenario A, you've got a strand of genetic material of your DNA, and in the central dogma, based on your DNA, you'd make copies of that, and you'd turn them into proteins. But what if that DNA is filled with stop switches? Then it's silent. Then no genes are made, no expression of those genes, and no protein. That might be protective for genes that make you too sensitive to stress, but it might be a problem if it affects genes that provide calming to the brain. So these epigenetic mechanisms can go in both ways. If that's still befuddling, I can tell you how I first mastered it a while ago, which is to think of fonts. If you've ever sent a text message, you know, it's just words and letters. Whereas if you kind of write a bulletin or a letter, you could put different fonts on it. You could make the letters purple or green or big. The content of the words is still the same. That's like the strand of DNA. But all the things you can do with fonts and make it look so different, that would be the epigenetic. You can strip that off and have the same DNA sequence. But over evolution, there might be some generations where you need to color the physiology of the species for a while based on an environment. And we'll see what us humans do with global warming, although it's coming on us quickly, according to some theorists, Americans, so you know, we have our doubters. So I mentioned the father exposed to severe trauma. This was an idea of a scientist named Lamarck, and he has this famous cartoon where the giraffes can't get the foliage in the trees, so the next generation has longer necks. That cartoon was built to make fun of Lamarck, and my high school biology teacher completely discounted him. But what I learned recently is that Darwin never discounted Lamarck. And Darwin was fairly sure that there was a form of evolution that was related to environments of parents that was changing the appearance of the young, which is pretty remarkable. Some of those changes we know can even be in the diet of pregnant mothers, changing the taste requirements and the palate of her young. But here's some kind of intriguing, I think alarming studies. So here's two studies of a mouse and a rat where they had identical little pups in utero, so all of the genes were shared. And in these two studies, what they did is they changed some exposures of the mother. So the genes are identical, but here's one where they altered the mother's diet, and here's what happened. Do these guys look like they share all their genes? One is little and dark, and one is big and fat, right? This is just by changing the diet of the animal. And then here's this little mouse, and what they did is they exposed this rat, the rat pups, to environmental estrogens. Now they're everywhere. It's one of the reasons a lot of people want organic meat that haven't been exposed to environmental estrogens. Environmental toxins, including many plastics and many pesticides, can activate our endocrine system, and they can really confuse the development of the young. So here is the mouse, the rat, when it was exposed to environmental estrogen. So these toxins in our environment can have a great impact on our physiology. Do we have more childhood obesity? Do we have more childhood diabetes? Right? So then there's this other question. You know, it's certainly not evolution, it's too short a time period. So we're wondering about the environment. Here's something else that's common in the environment, certainly in mine, I bet all of yours too, and that's stress. Now, stress of the manageable kind is inspirational and motivating and important, and a fetus can't develop without stress responses of the mom. But sometimes stress becomes really overwhelming. It exceeds our ability to adapt and manage a problem. Well, stress has very direct effects, even at any age. If I lost my keys and I lost my umbrella the same day, I sometimes have to think, okay, what am I nervous about? You know, it can really happen almost at the time when you're very stressed that your memory gets affected. Well, what we know is the part of the brain that gets affected by stress is called the hippocampus. Now, you want to think of a nice mnemonic, and you can think an elephant never forgets, but it's actually the hippocampus and not the hippopotamus. That is the part of the brain that we use for retaining memories. This part of the brain is very important because this part of the brain, your memory part of the brain that puts together the context, is making brain cells throughout your entire life. Now, we didn't know this when I was in medical school. We thought all the brain cells you'd ever have were there when you were born, and if you had a martini on occasion, you'd lose them more quickly, but maybe it was sometimes worth it. But now we know that the brain is making new brain cells continually. And of interest to me, because I study the sense of smell, is that 3 of the 4 regions certain to keep making new brain cells are in the smell brain, the olfactory brain, and another one is this part of the hippocampus. And those brain cells are manufactured continuously in part called the dentate, because it looks like little teeth. And those new brain cells join the circuit of your brain. Well, if you're under too much stress, the stress suppresses making the new brain cells. And if that happens long enough, you get major depression. All of the medicines that treat depression, even ECT or psychotherapy that helps, is related to making brain cells again. So all the medicines for depression are increasing the rate at which you're making new brain cells. Don't feel like you're a hero because you're not treating your depression, because untreated, the shrinkage in the hippocampus can become permanent. In the setting of a depression, when there's treatment, the volume and size of the hippocampus recovers. So stress and worry can decrease this structure. Depression will certainly decrease this structure. Treating the depression, antidepressant medications, ECT are related to a restoration of making those new brain cells. Now, there's luckily something else that's most powerfully associated with making new brain cells. That turns out to be running. Right? It's not endorphins that give you that good feeling when you run. It's brain cells. So the most potent signal to the brain to make some new brain cells is aerobic exercise. And I think of it as if an ancient human was running all the time, they probably had a problem to solve. But that's a big stimulus to make brain cells. So for people who are depressed or have psychosis or OCD, not only do they become socially isolated, which can make things worse, but they stop exercising. My former colleague who's now doing amazing work, David Kimmey, has shown that exposing people with schizophrenia, bipolar disorder, and those are the ones he studied, but to an exercise routine daily, led to an improvement in cognition that was measurable and a decrease in the negative symptoms, right? So here's a ready intervention for prevention and for recovery. And we know it's good to exercise, but if you follow the literature, exercise predicts every single disease we've ever studied, which is really amazing. I'm, for example, glad to be standing while I give this talk because I sit too much of the time, and sitting's not good for us, but exercising is particularly important, and particularly important for the brain. Another kind of stress can be that pregnancy stress. That pregnancy stress or any of these adversities, they can affect the baby's hippocampus in the future as well. So if the mom is stressed, the fetus makes an accommodation. It will be born sooner and it will be resilient. So it will survive despite smaller to the age of reproduction, but then after the ages of reproduction, those stressed babies, whether they're low birth weight or not, develop metabolic diseases. And you may have noticed again that overlap of severe mental illness and metabolic disease, and it does suggest some common signal that may relate to adversity. We studied the 6-day war in Jerusalem because the people in the birth cohort I mentioned, the 6-day war included that. And we were able to go back and identify the pregnancies and separate out month by month the gestational age of the fetus at the time of the war. And on the bottom here are weeks of pregnancy. And then we have the red bars, and those are telling you depression and bipolar disorder. And then the blue bars are the risk for the reds are schizophrenia risk, and the blue bars are mood disorders. And you see those red bars are really peaking in the second month of pregnancy. So that was the risk period for maternal severe stress, whereas the risk for mood disorders happened in the third month. But then at the end of pregnancy, see how those blue bars go up? There was also a risk of depression if you were born right around the time of the war, which was only, a brief period, but profoundly stressful for many people. We went back and showed that if you lived in areas that took direct shelling, the relative risk of having a child, if that shelling happened in your early pregnancy, was 32-fold. So that very, very severe threat and war exposure was having a big impact on the risk for schizophrenia. Now, if you had very high social status, that was protective. And we see that people who have resources or opportunities or support to buttress a stress do better. I've listed some of these other exposures already. So let me kind of wind up by talking about finding those genes, right? So I said that, only 15 to 20% of people who had a severe mental illness had a family history. So what can we learn about the genes that might be segregating? The first way we looked for genes was like a man who's walking home drunk from a bar and loses his keys. As the joke goes, he goes back and looks under the street light. His buddy said, "Is that where you lost the keys?" He said, "No, but this is the only place I can see." So I kind of liken that to what we used to call candidate genes. So we kind of go in and try to find the genes that worked where our medications worked, or dopamine, and we just keep looking at those particular genes, and we weren't able to find anything, or if we did, no one else found it. So those were the candidate genes. But then we got smart, and we got a way to look all across the whole chromosome. Right, so this is called the association study. So we just had a light on every chromosome, and we look there to see is there a region of the chromosome that's just always there when the disease is present. And thousands and thousands of people were added together until finally we have this plot that I'm showing you. It's called a Manhattan plot because it looks like a skyline. And this shows you on the bottom, chromosome by chromosome, where there were signals for psychosis. See that great big tall one there? That's your immune system. That's your major histocompatibility. MHC, it's the genes you test if you wanted to do a tissue transplant and find out if you were a match for someone. So the strongest signal by far for schizophrenia is coming from the immune genes, right? Now, people were surprised by that, although some people who did studies of psychosis way back in the day and looked at the immune genes because that's all they had, also found some immune gene links to psychosis. But there were a few other findings. One was that almost all of those genes for psychosis are also genes for other diseases. So schizophrenia, major depression, autism, bipolar, ADHD, most of the genes are giving you a kind of a vulnerability that cuts across diseases. So someone in a family might be at risk for panic or anxiety or depression. Someone else with that might have gotten psychosis. We don't have, for the most part, different genes for the different disorders. And that was a surprise to us, right? It's not like this gene predicts schizophrenia. We have this set of genes that are about how well neurons connect together, right? And that seems to be a predictor of many different kinds of psychiatric illnesses. So the common genes aren't specific. Another finding was that rare gene variants contribute to the risk. Well, rare gene variants. So for my work, I told you about the age of the father, right? This is showing you the slope of risk based on the age of the father. Our thought was, well, this is where the rare gene variants, and by rare gene variants, I mean we might have a gene, and maybe 50% of people have one version and 25% have another version, but people with psychosis are very likely to have a version of the gene never seen before, a completely novel version of the gene. The question, well, where did that come from? And our studies suggest that those completely new versions of the gene, those novel ones, are the versions that are the new mutations that occur in the age of the father. So our work would suggest that this is the source of those new genes into the population that might color that vulnerability to make it look like schizophrenia. And we actually went back into that birth cohort and we recruited cases whose mom and dad were alive and willing to be in the study, where there was no family history of schizophrenia at all. We got DNA from mom and dad and from the case, and we sequenced it. We looked at all the genes to find places where there was a brand new mutation. And 5 of those brand new mutations were right in the middle of important genes, and they caused that gene to malfunction. So that was interesting, suggesting that new rare genes can come in these sporadic cases. But next we went to a group of cases we studied in New York City, and we sequenced those same genes. And what we found in the end was 4 different genes were there, one of those 4 in a third of all the cases. And based on which of these rare ones were there, the clinical picture looked very, very different. From one of the genes, the one that begins with a P at the top, PTPRG, the people had high intelligence, but they had a very early onset of psychosis often. 2 of the 4 had preterm birth by more than a month. Another gene is called a transglutaminase. That's a gene that's actually implicated in celiac disease, an intestinal disease of wheat malabsorption, and that had been a leading theory for psychosis for many years. But maybe in rejecting that, we threw the baby out with the bathwater, because schizophrenia is not just one disease, it's a collection of different disorders. So we want to find the cases in whom a particular etiology might be the important one, because that will let us treat the disease. Another of the genes was a zinc transporter. It was the gene that brought zinc that you need in your diet out of the circulation and into the brain cells. And so that was a different one. Now, the cases that had that defect in bringing zinc into where it was needed for the cellular pathways, none of them finished grade school. They had the highest negative symptoms. They had severe depressions too, and all of these cases had made very severe suicide attempts versus none of the other cases. Some of the other cases had suicidal ideas, but these were very, very suicidal cases. And we call this the developmental type because these people had severe developmental disabilities from early childhood. Finally, we had another gene called ARMS here, and that's a scaffold for making brain cells. This gene is abnormally expressed in people with dementia. We found the cases who had it with schizophrenia had all excelled in childhood and gone through college before the illness began, and then underwent a sharp deterioration. So maybe this is Kraepelin's dementia praecox, right? In people who had been cognitively well and functioning, this was the onset of the degeneration. So we call these 4 different conditions within that umbrella of psychosis. And as we can confirm this and separate out more conditions, we can have some person-specific treatments. Now, I mentioned some of the IQ data. I'll mention the ones with the PTPRG. If you follow cognition and schizophrenia, they had a specific working memory defect. Working memory is how you keep track of what you intend to say at the end of a sentence once you begin it. People with psychosis often can't do that very well, so we can't follow what they're saying. This one called transglutaminase, they had a very slow processing speed. Their symptoms were mild, but every one of them had attention deficit disorder in childhood. So the conditions looked quite different, and significantly so in each of them. Now, the final thing that emerged from the genetic studies was that autoimmune factor that I mentioned to you. And that kind of brings me back all the way around to where I began this field. This is an article that was in the American Journal of Psychiatry in June of 1980, and it's written by a psychiatrist, Ralph Wharton. And it's called The Case of Ms. A, Accidental Lithium Treatment of Thyroid Disease Presenting as Mania. Well, it turns out, as I later learned, that Ms. A was my own sister, right? And her being admitted to the special unit at Columbia Presbyterian Medical Center and getting so much better was the reason I decided to leave industry and go back to medical school and try to solve psychosis. So on this unit, they wrote this case report, and it was the case that she had a fulminant thyroid disease, thyroiditis. Now, we know that thyroid disease is very, very common in people with severe mental illness, but also in their relatives. We also know that autoimmune diseases of all types are increased in the relatives of people who have severe mental illness. And I'll propose to you that a large portion of people with severe mental illness, the psychoses, but also depressions, have an autoimmune disease that's affecting the brain, right? And we have knowledge for a very long time that if we follow the brain scans of individuals as they go through adolescence into adulthood, what we find is that healthy adolescents are reshaping their brain as they go from the age of, going out alone at night to being able to drive a car, to being able to get a low insurance rate. So the brain is being continually sculpted as we go from our teenage through our late 20s. And in that process, we're cutting away connections in the brain that we're not going to need. What we know now is some of the signal of the immune genes for schizophrenia is something called complement C4. And it's one of the molecules that tags things to be destroyed. So if you were fighting off an infection, this complement would go there and then your body would wipe it out. Well, in some people who go on to get psychosis, their complement, the variability they have in this gene, makes it attack the brain connections. So we have this immune-mediated attack of the connections in the brain as the precursor to psychosis. And I think it's really revolutionary knowledge that ties so many things together. You know, we talked about stress and adversity and infections. All of those are ramping up your immune system, right? Even severe stress. If you've ever noticed, you're very likely to get a cold if you're under stress. It affects your immunity. So we now have the knowledge and understanding that an overactive immune system in a young person during the time of the reorganization of their brain between adolescence and adulthood may be the specific trigger for their psychosis. So I've told you a lot, and I've tried to give you a feeling for the plasticity of the brain, that the brain may be vulnerable, but also that there is enormous promise over time to better understand and harness types of changes that can come, types of changes in gene expression. And I'm still looking for and hoping for a cure for my sister, but also for the many, many other people who suffer so much from severe mental diseases, they and their families and the amazing clinicians who work so hard to cure them. So this is what I do. It's called translational psychiatry. So it's a little brain imaging, epidemiology, genetics. But in each of these studies, which, believe it or not, are interconnected, the goal is to bring the body of knowledge down to a specific person, to translate the science to an individual for prevention and for cure. And I could never do this work alone. I am so fortunate to work with amazing scientists across many different departments. And I will tell you, when you do science like that, it's amazingly joyful. So thank you for the opportunity to speak today. Thank you so much.
Questions?
Any questions? Please. Well, I would like to separate. So the question was, could any mutation in immune system functioning lead to this? And I will say that these are so far separate domains. So I'm talking about the relationship of stress, and I'm talking about different things that can color the illness, early trauma. I'm contributing to this discussion that the source of those rare variants is paternal age. Now, if you look at a lot of genetics work, they'll just find some variant in a gene is related to the illness. I'm interested in all variants of that gene that affect functioning. So that's what's different than just an association study. I'm finding all the mutations in a particular gene, and I'm seeing which ones are going to disrupt the function of that gene. So that's the rare variant part of the story. So we have a common genetic variation that usually doesn't cause anything, but can be related to any disease. I'm hypothesizing that those rare variants that are increased in schizophrenia, which is confirmed, are in fact being introduced by the age of the father. And so there could be a lot of different mutations anywhere. Separately for now, I'm saying the third finding from the GWAS study is immune dysfunction. And so for the immune dysfunction, so far, CCAR and the group has looked only at complement C4, but I think we'll find that other variations in immune-acting genes will probably also interact with inflammation, infection, and exposures, and that we're seeing an activated immune system as a very important component of the risk for all psychiatric diseases. Now, we can't just give everybody, Advil or something. We need the biomarkers for these people who may have an immune-mediated condition. We need to find the ages at which it acts. We don't want to wholesale turn down the immune system. That may make things worse, but there are exciting and promising leads of how genes may interact with stress or infection over a developmental time period to increase the risk for the illness. And your question is perfectly on track to illuminate that better. Any other questions? So, is it probable or possible if you have a person with schizophrenia to indicate what the cause is for that person? And I will say not yet, but we're hoping to head there. I mean, we also do it with my group, a lot of brain imaging studies. And we're trying to find in the brain certain biomarkers, not of schizophrenia per se, we're all the way past that, but of particular subtypes of the disease. So once we have those things called the biomarkers for the subtypes, then we can do precision medicine. But certainly for some individuals I treat, so 10% of people, based on our preliminary study, may have a defect in a zinc transporter. Well, do you know medicines like Depakote decrease the absorption of zinc? And all medicines for insulin resistance and diabetes affect the absorption of zinc. So I have started more regularly making sure that zinc levels are adequate in my patients in general. We usually think of zinc as someone's hair is falling out, but my colleagues in internal medicine now regularly supplement people with type 2 diabetes with zinc because it's very anti-inflammatory. So some insights from these may guide work sooner. The other gene I mentioned was called the transglutaminase, and that got me very interested in the intestines and gut disease. And a grant that I'm putting in now actually gets stool samples, fecal samples from people, and looks at the bacteria they carry in their intestines. If you've had a lot of antibiotic exposures over time, you may not have the healthiest bacteria in your gut. And we're interested in this. A baby who's born of a C-section doesn't have the normal bacteria in their body. It turns out that in addition to all the other marvelous things humans do, based on her environment, a woman who's pregnant concentrates different kinds of bacteria in the vagina before the baby is born. And during a vaginal delivery, those populate the baby as its first set of bacteria, whereas a baby born by C-section just has skin bacteria. So these are some of the newer puzzles. Below epigenetics and genetics is the fact that most of our genetic material as humans is the bacteria that live inside of us, and they do many important functions. So we're trying to see, autism is linked closely to gut disease and bowel dysfunction, but nobody's ever looked in detail in schizophrenia. Those who do find severe bowel disease, but people don't complain of it because the pain threshold is altered in psychosis. So we're trying to systematically look at the bacteria and bowel disease, particularly in young children who are getting psychosis, and see if that might be the source of active inflammation. So you can take these findings in different directions, but we're all trying to have precision medicine, whereas every person in the world with psychosis isn't getting the same medicine, but we know something about what might be individually protective. Yes?
I have a question. I also have a sister with schizophrenia, and at one point I got to consult her file, and the diagnosis was residual schizophrenia. And I just wanted to know is this a common thing, or what do you?
So I also do a lot of diagnostic work, which started because they did genetic studies, and if you do genetic studies, you really need to know diagnosis. So zip forward a few decades, and I worked on the DSM-4 and the DSM-5, and I'll be on the committee for the future DSMs. And we used to have subtypes of schizophrenia: paranoid, residual, disorganized, schizophrenic. They're all gone. DSM-5 got rid of all of them. So it's schizophrenia. There are no more subtypes. The subtypes didn't predict course, they didn't predict treatments. Residual might be that she still has some symptoms left after treatment. But if you've wondered about disorganized and paranoid and all of those subtypes, they're gone now. They didn't predict treatment, they didn't predict outcome, and so people don't have to learn those anymore. I thought that was good news. It's one of the few positive outcomes of the DSM-5. I don't mean that. Yes?
Well, my question is, would you say a little bit more about the impact of epigenetics?
The impact of epigenetics, absolutely.
This whole area.
Yeah, so we think about nature and nurture, or traditionally, as somewhat separate entities, but almost all of the exposures that have an impact have probably changed gene expression, and that is the epigenetics, right? So this is just where nature and nurture come together, right? Is in the instruction manual for making an organism. We inherited some genes, and some of those genes came with on-off switches, but based on our life course exposures, other genes have been turned on. Now that's probably beneficial over evolution. You know, if you have a bunny rabbit and for thousands of years they and their family lived in this little field, maybe they were very calm bunny rabbits, and then somebody comes in and they're building a big housing development or something, well, they can't stay calm little baby bunnies and still survive. So that change in the environment would make the bunnies more hypersensitive, more vigilant, right? So that exposure, that change in environment through epigenetics wouldn't cause a complete change in the DNA. That only happens over evolution, but in the short period would make changes. The diet of a mother during pregnancy will affect the taste preference of her offspring. And this is by turning genes on and off. So this is epigenetics, where nature and nurture come together and change the gene expression.
I have an interesting book by somebody called Bruce Lipton.
What's it called?
It's by someone called Bruce Lipton.
Okay.
On epigenetics.
Excellent. Yes, well, I think it's been very, very intriguing to understand epigenetics. It's answered so many questions we've had for such a long time. And a lot of times we'll use twin studies to try to see what's in the genes and what might not be in the genes. And when twins are discordant, meaning one has schizophrenia and the other doesn't, they differ a great deal in these methylation signals. Any other questions? Absolutely. So, and then your question is, well, is anxiety that runs in a family related to a gene that's being transmitted, or is it that stress signal going across the generations? I would say that severe ongoing anxiety and depression are pretty indistinguishable. And many people will struggle about whether it's depression or whether it's anxiety. But when anxiety is pretty ongoing, we treat it exactly like depression, and it probably has the same underpinnings. But I know people are very wed to whether they have anxiety or depression. Just scientifically and treatment-wise, it doesn't make such a difference. But that's an important question. And anxiety and depression in particular are related to this prenatal adversity.
So it is hereditary in the family?
It can be, absolutely. It's increased in families. But remember, depression is so common and anxiety is so common that even if you have a family history, it doesn't change your risk that much because there's such common conditions. But depression and most of anxiety, really people can get expert care for now. I mean, it saddens your heart that major depression is the #1 cause of disability, worldwide almost in the developed countries, when I see it as the most treatable of all chronic diseases. So really want people to get evaluated and better treated for depression. I do have this radio show, I do. And whenever I can, I just talk to people again who may be randomly changing the channel about getting better help for their depression and anxiety, because it's the greatest affliction. Yes?
What is the best help for depression and anxiety?
Well, I think for the young people, it's really a cognitive behavioral psychotherapy. I mean, a lot of people have not been well soothed. are used to being distracted. So, if we have a problem and, we were born a long time ago, we might sit with it, might read, might call a friend. We learn self-soothing. When the baby cries and we pick it up, we're teaching the baby self-soothing. If somebody's restless and they're a few months old, we'll distract them with a rattle. And that rattle, is teaching them a little how to distract themselves and calm down. But I think too many young people, instead of learning how to self-soothe and regulate their over-arousal or reframe things, will just go on the internet or just go to a device, not get the social contact, not get the support, and not learn that self-soothing. Some places have tried to teach breathing to young children because you can't stay anxious and control your breathing at the same time. Years ago, if you had a panic attack and went to the hospital, they'd give you a paper bag to breathe in. Anybody ever heard of that? Well, it turns out the reason that it worked had nothing to do with the air in the bag. It was just that while people were breathing in and out of the bag, they were controlling their breathing. You can do that without a bag and without the hospital, but that's a way to calm yourself down from the inside.
So have places that have started mindfulness, I hear that's...
Yeah, this is mindfulness. Yeah, so this breathing is a kind of mindfulness. Mindfulness is taking your cognition and your awareness away from inner directed thoughts and being connected to something in your environment, being mindful of the things around you. Nobody's ever solved a rumination or anxiety by thinking through the best thing to do. When that happens, it's because you were able to have a good night's sleep. You wake up in the morning and you're like, aha, I know what to do. But if you're just brooding and anxious, the mindfulness, meditation, breathing, learning self-soothing is very, very important. Yes?
Do you advocate men having children young?
I advocate for sperm banks and boxer shorts. That's an old joke. I think, the vast number of children of a man of age 60 will not have a disability, and I can't really do that because the risk maybe goes up to 4 or 5% of the offspring of an oldest father. But my sister has schizophrenia. I chose to have a child, so it would be paradoxical for me to tell gentlemen what to do. But I think we all need to know our own risks. And the fact is that this risk of older paternal age has been completely well known by the American College of Genetics Counselors since the 1960s. For any disease, the risk doubles in the 30s, triples in the 40s, it goes up from there. But they never bothered to inform the public about it because their thought was, well, what would they do anyway? Whereas for women, the kinds of conditions that accompany aging, like Down syndromes, are whole extra chromosomes. So the thought was, well, we can look for the conditions that will affect women. But those are minor compared to the vast majority of conditions that really are paternal age related. So no, I inform and people make their own decisions. Safer that way. I've been yelled at from both sides. Thank you all so much. Oh, wait a minute.
Given that Donald Trump fathered his last child in his mid-60s and probably endowed him with all kinds of risk factors, would you suggest that he may be even more difficult than him?
Absolutely not. Many levels of meaning.
Thank you very much. Thank you very much for coming. Thank you very much for